Algebra 2, we have 5.5 today. We are going to be doing operations on functions. So we can add, subtract, divide, and this is kind of like multiplying or substituting in, I guess. So we have addition. We are going to see that as f plus g in parentheses. So f and g are going to be our functions, and it'll be like f of x and g of x. So we can see that f plus g of x is the same as f of x plus g of x, and we're just going to add them up just like you normally would. Same thing with subtraction, f minus g of x or f of x minus g of x. When we're dividing, you would just see f divided by g of x. Then we would split that into the f of x function over the g of x function. So we're going to make that into a fraction, then just simplify. And then we call this the composite. So it's f composite g of x. And you're actually going to take the second function and plug it into the first function. So it's like we're substituting it. So we're going to take like f of g of x. So whatever g of x is, you're going to plug that into the variable for x. So plug the second function into the x of the first function. Let's see this. So we're going to find f of x minus g of x. Well, f of x we're going to say is 7x minus 13. G of x is 6x squared. So we're just going to simply take f minus g. So 7x minus 13 minus 6x squared. And you have to do kind of distribute that negative sign. If you only have one term, you really don't need the parentheses right here because obviously you're going to have a negative. But if there was 2 terms or 3 terms or 4 terms on this g of x, you'd want to distribute the negative to every single term in the problem. And then we're going to rearrange it in standard form. So standard form just goes highest exponent to no exponent. So we just kind of reorder it, negative or minus negative 6x squared plus 7x minus 13. And then since there is no fraction or root, we can plug in any number into x. So our domain is all real numbers. So there's no restrictions on what we could plug into the x's. Here they want us to find f divided by g. So obviously you cannot have a 0 on the bottom of a fraction, so g of x cannot equal 0, so that would be a restriction. F of x is 5x squared minus 5x minus 30, whereas g of x is just x minus 3. So when we divide, our fraction is going to be 5x squared minus 5x minus 30, all over x minus 3. So this tells us, since the bottom of our fraction cannot be 0, x cannot be 3 because 3 minus 3 would be 0. So we have this restriction right here. Let's factor out the top. So what do 5x squared, 5x, and 30 all have in common? 5 goes into each of these numbers. So we're going to pull out a 5. And what's left over? X squared, because 5x squared, minus x, because minus 5x, and then minus 6, because 5 times negative 6 is negative 30. So then just looking at this quadratic right here, we can factor this one step further. Remember, we're going to add to the middle and multiply to the outside. So what multiplies to negative 6 and adds to negative 1? Negative 3, so x minus 3, and x plus 2. We can simplify this. We have an x minus 3 on the top and bottom. So what do we have left over? 5 times x plus 2. And reminder from up here, x cannot be 3. Here we're going to find that composite. So we have f of g of x. So we're going to take that g of x right here, x plus 10, and plug it into the x of this f of x. So this turns into, this would be like 6x minus 4, because here's our x and here's where we plugged in. So 6x minus 4, and we just plugged in this x plus 10 where the x was. So we're going to distribute. So we have 6x plus 60 minus 4. That gives us 6x plus 56. Last one, we have the composite of f and g. But we're going to plug in negative 5 for the x. So first, we need to find g of negative 5. Since that's the second function, we need to find g of negative 5. So g of x is x squared plus 4. So now we have negative 5 squared plus 4. Negative 5 times negative 5 is 25, plus 4 is 29. So now we're going to take this value of 29 and plug it in to our f, because if g of negative 5 is 29, our question is really now going to be f of 29. So f of 29, we're going to take that 29 and plug it into our negative x minus 1. So negative 29 minus 1 is negative 30. Therefore, f composite g of negative 5 is negative 30. If you have any questions, ask your partner, use that question help, view an example, or help me solve this in the top right, or shoot me an email.